Hi, everyone. My name is Gustav Düsing. I'm an architect from Berlin and also professor of architecture. And I'm very happy to be here. Thanks for the invitation. You have a beautiful campus here. I took a walk today. I think you can be very happy. It's nothing like what we have in Europe, that scale and these kind of open spaces in between the buildings and the facilities, and everything is really beautiful. So I'm here to also speak about the project that we won the EUmies Award for. But I will also show a few projects that somehow are important to understand where we were coming from. And so it will build up towards the end when in the grande finale, I show the project that has already been shown quite a bit here, but I will explain what it is about. So the first project takes us to Antarctica, which where I was invited in 2017 for the first and only architecture Antarctic Biennale. It was a project where architects, artists, philosophers, journalists, scientists, all were invited to go onto this research vessel. And then we went onto a nomadic journey through Antarctica. And so when I started thinking about Antarctica, I was looking into the history of it. And if you research the history of Antarctica, there's no way around looking at the endurance expedition. And for those of you who don't know it, it is very legendary because they never reached Antarctica mainland because they got stuck in the pack ice immediately. And so they were there for a year or something, and then the ice started crushing the boat. And so it got destroyed and they had to leave it behind. And this expedition is very well documented because they had Frank Hurley on board, he had like the latest, newest equipment, and he was also filming. And if you ever want to research into the topic, you will find very amazing footage where they try to escape the ice but couldn't manage. So here in this scene, you see the moment where the boat was finally given up and they had to rethink their means of transportation and means of housing in order to survive. And so let's say the boat was already a movable piece of architecture, became immobile, and they had to somehow settle into a new mode, which was dog sleds and tents. So in a way, for me, that was an interesting approach to this continent, the idea of movable architecture that does not leave a footprint, and the idea of cutting down your comfort demands in order to survive and be mobile. So the story ends that they actually traveled for another year or something over the ice, which was not a flat surface, but rather difficult terrain. And they came to an island, and then some of them got onto a rescue boat that they also dragged all the way over the ice. And then they got rescued after 3 years, and nobody died. And so that's the legend. And so for me, it was somehow obvious to design a tent to bring to Antarctica, a light piece of architecture that I could also take on the plane with me. And so the scale of it also responds to my means of transportation. And so this is when we cross the Antarctic Circle, and you see icebergs, and then we reached the Antarctic Peninsula, and there were lots of humpback whales. And so Antarctica has a very severe climate, as we all know, and also a lot of waves. And so at a certain point, the conditions were right in order for me to go on shore and realize my project. the idea was to bring a tent, but to somehow respond to, let's say, the cultural conditions of Antarctica, which means there's no permanent settlement. It's not allowed to build a house on Antarctica. And so I was designing something that is somehow responding to this matter. At the same time, I wanted to be climate specific. So I researched into a technology where you spray cotton with water, and then it starts freezing and becomes a structural shell. So in the morning, I went on this beach to set up this tent made of very basic cotton. And I designed it so it blends in with the surrounding of Antarctica. And I set it on this beach for two reasons. One is the beach is the only chance to actually get on shore, because the rest is really these cliffs and glaciers. And secondly, I found it romantic to have a tent on a beach. And it kind of talks about the touching of unspoiled land and the embracing appreciation of landscape. And so this beach was used for cutting whales back in the past, and you see these bones everywhere. And it's a penguin colony. And so I started spraying the tent with water, and it takes a while because it needs to be really wet. Also, then it stops moving so much when it's wet, and then these penguins are very friendly. And so when it got darker, it became cold enough for it to start freezing, and then it really becomes this rock solid surface. And through its geometry, it also became like a origami structure, kind of performing with these kind of triangles. And so when the temperature changes, the tent starts melting, and it's very fragile and soft. And so the idea is that you use climate conditions to create a piece of architecture that only exists in these specific conditions. And when they change, the architecture goes. And so also the idea is that you invite the climate into your architecture instead of, let's say, in the traditional sense, trying to somehow work against it. And now that it's so cold here and there's a blizzard coming up, I would all invite you to try out this technology. It's fun and it really works. So a few years later, the Corona pandemic hit. And somehow it reminded me of Antarctica in the sense that it was about bear survival. And me and my friend Carsten Chen, who is a curator at MoMA, and we were on Zoom talking about what is new for architecture. And we all remember that it was very obvious that the pandemic was also a spatial question, where there were suddenly these marks on the floor where you had to keep distance, where you would, continents would shut down, countries shut down, cities shut down, boroughs shut down, apartments shut down. And in the end, you sit in your own room, doors locked. And so it's about subdivision of space. It's about isolation. And it's about time as well, because there was this period of, I think it was in the beginning, was 14 days. And so we started looking at architecture that responded to these this new phenomena of a pandemic. And on the top left, you see a drawing that I found somewhere about the Spanish flu in Northern Africa, where you see there's a village, and on the top there, in between those houses, there are some tents, and then there is this image of an interior of one of those houses where there's also some subdivision, and families sit together underneath a certain umbrella, and then we remember those images where there were these kind of cardboard walls and curtains, and people were asked to stay there for 14 days. And on the top, on the bottom one, this is an historic example from Ancona in Italy, where seafarers had to spend 40 days quarantine when they arrived on mainland before they were able to enter the country. So this was the starting point to think about a piece of architecture that somehow responds to this new set of conditions. And then we made a video, and the video should somehow speak for itself.
In a short few weeks' time, the 2020 coronavirus pandemic has revealed architecture's inadequacy in responding to environmental and health crises. If humanity is entering an age of pandemics, quickly constructed field hospitals with rows of identical hospital beds will not be sufficient in addressing the increased amount of time we will need to spend in quarantine. The ecosystem, the natural world which includes coronaviruses, does not operate within fixed spatial and temporal frameworks. Viruses bloom, proliferate, and vanish unpredictably. Pandemics will become a regular feature of humanity's future. Before vaccines for new viruses can be developed, the most effective way to stop viral spread is by codifying social distancing guidelines. Virus outbreaks don't occur within fixed borders and timeframes, so neither should architecture's response. The global development of viral spread is hard to predict. An architectural response needs to be like a virus: adaptable, mobile, scalable, and resilient. The virus is not fixed in space and time, neither should the architecture designed to counter it. The pathogenic world increases the space and time between us. The Responsive Care Center is a distributed, scalable, transportable medical quarantine facility, deployable in multiple locations at the first sign of a novel virus. Depending on the nature of the disease at hand, the Responsive Care Center can be rearranged to accommodate various residential densities. The building consists of spatial layers. Movable antibacterial fabric hangs from the tent, separating interiors while allowing light to pass through. The architectural unit is essentially a system of tensile fabric atop an infrastructural plinth. Each resident is given their own private quarters, fitted with a built-in shower, toilet, and work area. A hutch allows for contactless delivery of meals and medicine. Plugging into existing networks, the Responsive Care Center is like a branch grafted onto a tree, bringing in energy, supporting health. Rather than the logic of efficiency, the architecture of the Responsive Care Center follows the principles of salutogenic design, a method of design that is focused on health and well-being rather than disease. The 2-week quarantine period, a fortnight, introduces a new social category of space and time. A new conception of time will produce new cultural phenomena. Neither a vacation nor a seamless continuation of daily life, the time spent at the Responsive Care Center will combine work with healing, self-care with self-awareness. Fortnightism is a new paradigm born of both uncertainty and diligence. As a method, fortnightism dismantles human supremacy by insisting on humanity's precarity in the face of climate and ecological change. Healing and reshaping both the body and the mind The center challenges Western habits of consumption and comfort. What temperatures can we accept without artificial heating and cooling? How should we define personal space? Fortnightism builds periods of slowness into our lives. It is a revolution by deceleration. Tent fabric fitted with photovoltaic cells covers large expanses. Stored in shipping containers that double as clinics when deployed, the lightweight tent structure is easily shipped to any location experiencing an outbreak. Understanding viral outbreaks as a sign of imbalance in the natural world, an imbalance caused by humans, the Responsive Care Center is also a training facility for a new relationship between humanity and the world. Through the Responsive Care Center, fortnightism emerges as both a defense mechanism for the well-being of humanity and an architectural technology for multi-species cohabitation.
Yeah, so there were ideas about an architecture that is not bound to a specific location, an architecture that is scalable, an architecture that is lightweight, and an architecture that also questions comfort demands for the stated reasons. Can't have it all, is what it says somehow. And obviously this is a kind of provocative idea. It's dystopian, we know that, but we wanted to somehow also experiment with the idea of a certain condition and then take that as a brief to design a piece of architecture that responds to it. So the idea of an architecture that is responding to specific climate conditions kept on being one of my interests. And when I was in Antarctica, that was a very cold climate. But then a few years later, I was doing a fellowship in Rome, and there was very hot. And so I was wondering if some of the learnings that I got from Antarctica can now be somehow transported to Rome and maybe make use of the weather there. And so I designed a material system that works with solar power. So I had these two solar panels, and so I was gaining solar energy, and that was then firing this little motor, and this was spinning this big piece of fabric. And through the centrifugal forces, and the thing starts building up a space, and this space is in direct relationship to the available resource, which is the sun. So there's an idea about a direct translation and also a programmatic translation. So now that the sun is out, the space is big and creates a microclimate. So it was windy and a little bit cooler than outside. So this, let's say, climate modification plus the definition of a space was attractive to my fellow residents. So they used to come over for a fresh breath. And so in a very abstract way, it became a communal space by its size and by the communal enjoyment of a modified climate. And the geometry that you see comes from a laws of physics called the Coriolis effect, which is when you have straight vectorial lines of movement being applied onto a spinning surface. And this is also something that if you look at the jet streams, if you look at the planet and there's a northern hemisphere and then you see the jet streams, they look the same because it's the same principle. It's the winds are applied onto the spinning globe. So there's an idea about atmosphere and architecture and the scaling down of those elements. So when the sun was gone, the space became small. And so when we had guests, we used to put a bed in there, and it became a private space. So it's somehow what I want to say is that, you know, there's a resource, you can create a space out of it, and then you think about what kind of space it is, rather than, let's say, the traditional way of wanting to have a certain program, and then for whatever it means, you try to get your resources together. So here it wants to kind of flip this principle around. So these ideas were out there, and the question is, can this ever be some sort of architecture? And so we were asked to design a social space for this factory in Cologne. And it's a very interesting piece of architecture. It's designed by Nicholas Grimshaw, who's a British architect and known for being part of this kind of high-tech architecture movement with Richard Rogers and Norman Foster and these people. And so this factory is a modular system. On the left, you see it's a square a module, and this can be added. And now they started off with one in the 90s, and now it's this big, and it even continues on the other side of the street. And so it's this kind of donut-shaped space, and in the middle there's a courtyard. And in the courtyard there's a pylon, and from there the roof is suspended in order to have a column-free space. And inside of the factory are these plastic, they do these movable plastic parts, and the machines are running 24/7. And it's really hot in there and very loud. And it's very much a machine space, very dystopian. Humans don't play much of a role in there, even scale-wise. And so the client was saying, we need social spaces. And so we said we could come up with a concept for these courtyards because they were up for grabs. There was nothing in there. And it's an interesting side condition, being at the foot of this pole and within this square courtyard. And so I tried to remember the ideas from the previous projects. And so I said, okay, maybe we look at this courtyard through the lens of a heat camera. And this is obviously a drawn diagram, but let's say if we would have looked at it from a view of a heat camera, it somehow would look like this. So the interior of the courtyard is cold, and that's why it's blue, and the factory itself is hot, and that's why it's red. So we said, okay, maybe if we want to continue with this idea about minimal resources, how about we introduce a simple, let's say, tent-like structure in there. And together with these climate engineers called Transolar, we made these calculations, and we said, okay, if it's maybe 6 to 12 degrees, with the simple tent structure, you would maybe already scale up the temperature if there are people inside. So, but it's not still up to comfort standards as we know them. But the question is, if we demand comfort standards, let's say, I don't know what it's in Fahrenheit, but in degrees, you would have Celsius, it would be 20 degrees is like the usual interior temperature. But if we go lower than this, maybe we have to lower also the time we will spend in it. So we said, maybe in this, let's say, slightly conditioned interior, we can do things that maybe don't take as much time. So you can have an espresso, which is very quick, or a piece of cake, and you have a short meeting or something, and that you can do in 15 minutes, and you don't freeze to death in there if it's just 15 minutes. But then the client was also saying, yeah, but maybe we want to do something a little bit longer than 15 minutes in there. So we said, okay, maybe we introduce another climate zone in there, which is even a little bit hotter. And with this climate zone, you do maybe things that are lasting for like an hour, like a lunch, or like a little bit of a longer meeting. And so we said that there are 3 different climate zones. There's the exterior, like outdoor, and then there's indoor, which is this now. And in between of that, there's what we call mid-door, something in the middle of that. And then we obviously proposed to extract heat from the factory and pump it into those, what we call space pockets, because the heat was omnipresent. And so our climate engineers, they made this calculation, which is in German, but I can explain. Top bar would be if you wouldn't do anything to the courtyard, and you would see that more than half of the year it would be too cold. And then the middle one says if you just introduce a simple skin, then you already see, okay, half of the year it's fine. And if you put the simple skin and the heat from the factory, you suddenly get 90% of the year an okay interior climate. So we developed this structure, which was a circular funnel-like tensile structure. It's circular because on the one hand, it really fits well into a square courtyard. And on the other hand, if it's a circular ring and you have a tensile structure in the middle and it pulls it together, it acts like a compression ring and like a bicycle wheel, and you can make this ring really, really thin and therefore also light. And then we said we have this elevated plinth, which is a modular system where you can take out some of those grids, and below those, the surface, there would be a system of pipes that collect the water from the interior and pump it into those flower pots. And so the idea is that this would become a self-sustaining system. And also we used to pull down the central ring and fix it onto the foundation of this pylon. And it was somehow, yeah, a bit funny because there's this 30-meter pylon holding up the whole roof, going down into the ground, and we just lifted up a tiny little bit with our structure, somehow like a parasite, but not doing much. And so this was then our image that we presented to the client, and you see that, you know, it's open and water comes in and gets collected there, and then people sit in those space pockets also made of fabric, and everything is light, and we use very little material. And then the question is, okay, this looks like a winter scenario, or like what happens when the sun comes out? And then we said, okay, maybe we take those pockets and we just bundle them together so they create these like umbrellas, and they make shade, and then the side of the pavilion is completely open. Yeah, and then how it is with these things, we got building permission, and then the client stopped it. And also, yeah, in Germany, there's a bit of a recession happening, and people are keeping their money tight. And so this is waiting to be realized. But you know, the idea was there, and that's already something. And the question was, can I maybe think about a system that is modular? And this then also already points towards the project that we were doing for the university in Braunschweig, and is a tensile structure, and is mobile, and is scalable, and is transportable, and storable, all these things. Can I combine all these elements, or these, let's say, qualities? And I started messing around with these hyperbolic surfaces. We all know those, kind of Pringles shaped. But what I was trying here is that I wanted this to be on a square grid, and I wanted this to be self-interlocking, so it doesn't need to have any suspension, any foundation, and therefore it's sightless and movable. And with this idea that you have a square element and it all has the same edge length, you can then start producing tons of shapes, and you know, endless variations. And we fabricated those elements and we set it up in a forest near Berlin, and we called it Picnic, because the picnic is a really beautiful social activity, and it talks about a small group of people collectively going into a beautiful setup, bringing their things, enjoying nature, being social, and when they leave, they take everything with them, and they store it away. And so this installation somehow was a representation of all the ideas that I was collecting. And on top of this meant to be a sun shading device. And then it's also a climate conditioner. It changes the climate. You have shade. And if you have a modified climate, people like to come together. Yeah, and then we took it to a gallery in Berlin, and yeah, also in a way showed that it's transportable, simple as that, and set it up in front of the gallery. People were like sitting below it. And then there was Berlin Art Week. It's a huge art festival in Berlin, and there's a Gropiusbau. It's a big museum in the center of the city, and they have a garden. And so they asked me if I want to set up this picnic in the garden. And it was already autumn, and I was not so sure if I want to bring my beautifully crafted raw cotton things into the rain. And so we decided to change the surface and took this wrapping foil and wrapped them really easily. And then it was kind of protecting people against the rain. We changed it from sun to rain. And it was beautiful because actually it worked out. People were using it. They could have sit somewhere else. They could have used a chair, but people decided actively to crawl down into those spaces. And yeah, I like to somehow think about it as if you would build a little house for birds, and then you put it in the tree, and then you wait for the first bird to go in. And yeah, it was beautiful to see that, you know, you have to somehow mark a space, and people they appreciate it and they want to sit in it for whatever reason. It wasn't raining even. They could have totally not sit there, but they did. And so these ideas about structure, membrane, space, scalability continued. And then I was I was a guest professor in Rome. And with the students, we kind of thought about structural ideas in the spirit of Frei Otto, and maybe also Jona Friedman, who was envisioning these endless structures, which I also I would come to. And so students were very happy because they came out of Corona, and they were not just doing online teaching, and then we did a fully physical year, and it was very large scale, and no special skills required. And so the idea was that you somehow think of frames that are in compression, and then you have membranes in tension, and these things somehow like interlock. And our structural engineers always say that it's like you would take the forces for a walk around the structure, and then they get back, and then it's interlocking. So this was beautiful, and could have been endless. And now, I think this is the last project I'm showing before I actually get to the point. This is a competition that we won recently, and it is a building for an architecture faculty. And it's special because in Germany, we only talk about the Bestand, which means the existing building, because we came to the conclusion that the most sustainable building is the existing building, and the worst thing you can do is demolish that. So some smart people in the middle of Germany. They are in the city of Siegen. Doesn't say it here, but it's a small town. They have an architecture faculty, and this faculty is right now, it's like a little bit outside of town up there, and it's not very attractive. It's not connected to the city. And at the same time, the city is having a problem with declining retail, and the city is a bit dying, which is probably also happening here because of online shopping and these things. And so the idea was to bring the architecture faculty back into the city, so to create a new, let's say, urban attraction, to have urban like students all over the city, and so the city was happy with that idea, and they chose the site, and they said, yeah, there's a building, but you can demolish it. It's not anything great. It's this. And then the architecture faculty was saying, no, it's a beautiful building, has to stay. And yeah, I would say it's not specifically beautiful, but it's an interesting building, because it's a kind of catalog. It's a building, a kit of parts of prefab concrete elements that you can order in a catalog, and you can make this building as long as you want. And there are loads of those around Germany. So in a way, it's also a prototype to actually look at this building and see how you can transform it. So this was set, that they said, okay, this building has to stay because it's the most sustainable way of doing architecture. But obviously it's also too small and doesn't meet all the requirements that you have for an architecture school. So they decided to set up a competition. And this competition they designed so it's very low barrier, and it didn't require much of a big office and lots of turnover and tons of employees. It was rather about having okay references. And we just finished this building in Braunschweig, which I will talk about. So we were able to get into the competition, and it was beautiful because there were only 6 offices invited, and they set up a summer school at the beginning of the competition. So me and 6 other offices were invited to come into the space, and we all got 10 students each. And so for a week, we were somehow already doing what was supposed to be happening in the space, teaching architecture, and the subject was what to do with the building. So it was a very, let's say, fruitful come together. And it was boiling hot in there in the middle of summer and very intense. And so we somehow asked ourselves the question in that process, what's the role of the university in the city? Simple as that. And you have a beautiful campus, like I said, but it's really that this building wants to be an activator for urbanism, and that the pedestrian zone that is ending somewhere a little bit up north from there will continue along the building. And then the question was, how can we create a link between the architecture school and the city? And we said that it needs an architecture museum and a cafe. And the great thing about the competition was that they never gave us any program. They were like, this is the building, and you probably know better what it needs. So we had to really just come up with everything ourselves, which I find very refreshing, because often if you do a competition and everything is already lined up for you, it becomes this kind of puzzle and it's not so stimulating. And here we would be able to really come up with a program. So we have this ground floor, and there's a river here, and it's really there's no barrier, so it's really street level. And then there's the spaces for architecture school as we know it, which you have here, which is also very beautiful, I think, and it's continuous space and very great acoustics, and I found it very calming and easy when I was walking these spaces. So we want something like this as well. And on the top floor, there is a column-free big space that is overlooking the city. And so the question was, how can we do all this with the least amount of material? Because this is our somehow aim. And so we decided that we want to top up the structure with a structure that is only, or let's say mainly, working in tension. Because again, tension means less section. Like, you know, if you have a metal wire, you can hang a lot of loads on it, but if you want to put the same loads on a pole, then the pole is much thicker. So putting the whole structure in tension was our goal, and we said that it can be a bit like a drape. Whatever we put on it kind of falls over the existing structure. And so we have this hanging roof on the top, and it's made of timber, and you can put timber in tension, and it's very light. But the thing is that if you have a hanging roof, when there are wind loads, it wants to take off, so you have to put weights on it. And if you put weights on it, then the columns, they want to fall in like this, so that's why you have to suspend it. And usually you do that with foundations, but we didn't want to bring any concrete onto the site. So we said that by having those side spaces, they are the counterweights for the hanging roof on the top. And at the same time, we were also again looking at climate as a, let's say, organizational principle. And so we had a heat camera in the workshop, and we were looking at different scenarios in architecture school. And here, and I don't think it's much of a so common a ritual, but in this summer school, we had a speaker's corner where we would come together and we would debate. And this debate was somehow quite wild. And so you see the temperature 35 degrees, 37 degrees, it's hot. And so let's say this, I put this picture into this presentation because what I'm trying to say is that not all activities within an architecture school need a proper interior climate. So again, we designed spaces that have a different climatic interior. And if you, for instance, these parts here, we decided to not heat at all, which then within our very strict building laws means that you don't have to meet those building laws because you don't heat them. So it really works like a greenhouse. You can use very thin metal profiles and single glazed windows, which makes the structure very light and very resourceful. And so in a way, these, we call them cheeks, or like, yeah, we put them on the exterior. They in the summer, they work like a exterior sun protection. And then you open those up, and so the hot air can escape. But in winter, you have them closed, and still the solar radiation heats up those spaces, and they help the building perform better. So you need to heat them less, spaces. And at the same time, there's this river, and we developed a system of a diagonal ventilation. So in summer, this cold breeze can go through. And this is also from the summer school. Obviously works. This is definitely cooler here than next to it. But you know, that was a starting point of a thought process. So then the design was coming together, and this is how it wants to look like when it's built. And this is the part of the river, and we had to take down those facade elements, these prefab concrete facade elements, in order to free weights from the structure. And we put them there to create these islands. And when I presented, I used to pull the joke that the city is not entirely sure about this approach here because they think that we are just dumping rubble into the river, but it's actually our design approach. And so you see also that this there's no real barrier to the river, and the river has these flood scenarios. And we were thinking, and that's also quite provocative, and we don't know if it goes through, that if there's a flood scenario, we just let the building be flooded, and we just move all the furniture, which is on wheels, and we just move it on one floor up, rather than having a wall, a barrier that then again somehow separates the city from the river, and also makes it less accessible for elderly people and people in wheelchairs and all these. So idea was that the building is ephemeral, and we think about it as a sort of post-climate change architecture that doesn't try to kind of stand against nature, but rather just gives up, and lets the flood go through. But I mean, I don't know if this will be okay with the local planning law. We're not there yet. Yeah, this is the interior, and yeah, it's a bit of a collage, and you can see how we kind of beefed up those beams, which were okay for having a roof, but now that we want to put another floor on top, they had to be stronger, and we kind of supported them with these exoskeleton steel structures, and altogether it creates a certain new feel, which is a kind of bricolage style, but maybe it's what yeah, we should get used to by somehow reusing building stock and trying to work with the things that we have rather than throwing them away. And this is the top floor. You see the hanging roof made of timber, and the space shall be somehow in between stage and backstage, where students can practice their presentations, and then the space can be turned around into a presentation or like a lecture hall. And so this project, we won the competition also maybe because we came up with this mega model, showed up at the competition, which was not required, but we couldn't help it. And with this scale, it's a 1 to 50, you can also really test out the structural system. When you press the roof down, you can see how the balconies go up. And so yeah, so we won the competition, which was fun, and now we are in the process of getting started, and it's also a very long process. This is the so-called money shot, and let's see if it will turn out that way. It's gonna be a long fight, but yeah, so we continue research. This is now from my teaching in Berlin. We looked at also demountable structures and reusable structures. So we went to see power plants, and in Germany there's the so-called paradigm shift away from fossil energy to renewable energy, and that is a law, and by 2038 the last coal power plant will be shut down. And so these structures are there all over the country, and they are huge, and they are made mainly from steel, and they are modular, they are demountable, and they have very exciting geometries. And so the question is like, what to do with it. Can we as architects maybe get inspired by these? Can we think of structures that we somehow take from those elements and bring into the city? And at the same time, these, yeah, that's very, yeah, I mean, you can tell, right? It's exciting. You can do a lot of things with that. And it's all steel. And usually when they get demolished, they really just crush them down, and they take the steel and they melt it. But I believe that these elements here, they can be used for something else. And at the same time, these power plants are also weather machines. You know, they have a lot of different climatic zones in there, and they create clouds, and there's fire. And if you have ever wondered what it is like to be at the bottom of one of those cooling towers, this is how it looks like. It's a very spectacular space. It rains always in there, and a lot. And the water is clear because it's really just the steam that cools down. The dirt that comes from another chimney. And so you can actually drink the water if you like. And yeah, it's fascinating. It's a space of fossil fuel energy, and we look at it with a bit of nostalgia. We're not gonna keep them going, but we at least wanted to look at them and appreciate them one last time, and also yeah, document them. So students are now going, they are doing designs with it, and they are pretty much finished, and they designed these videos, and we're going to show them in an exhibition in the German Architecture Museum. And so this is all the build-up to finally talk about this. So this is the project that I did the competition with Max Hacke, my friend that I studied with in London. And when I moved from London to Berlin, I worked for Barco Leibinger, which is an German-American office. And I stopped working there because I wanted to set up my own practice, and I also wanted to start teaching. And I started teaching at the TU Braunschweig Technical University, Braunschweig. And it's in the middle of Germany, and there's this campus, the central campus, and it has lots of different building types. And there is the tower, which has the architecture faculty, and then there's the kind of post-war modernism with a really beautiful lecture hall and a library. And so when I started working there, pretty much the first month or something, there came an email saying that there's a competition for the teaching staff, for everyone who's an assistant professor in architecture and civil engineering can participate in the competition. And the idea was to team up and submit a proposal. And by the time I didn't know anyone there, so I asked my friend Max if we want to do this. And I said, it's obvious that this is a really great opportunity and these things don't come that often, and we should really go for it. And he agreed. And then we looked at the brief, and it was about actually, first of all, to build a house for desk space here, but then they moved the site to here, which is even better because it was much more central, and it's really the first thing that comes up if you walk from the city to the campus. And so it was about desk space for all faculties, and we looked at what is already there and how students already use campus. And the architecture faculty, they have a tradition which is called, like, if you translate it into like drawing rooms, and these are not like here. They're more spaces that the city rents, that the university rents, and they are fairly small, and they are somehow autonomous, and they will be handed over from generation to generation, and students are kind of maybe like a fraternity somehow. Like they are in charge of these spaces, and they can work in there, and they have, you know, they have printers there, and they throw parties in there, and they spend their weekends there, and there's no authority, so it's really no hierarchy, and so these are around, and this is quite a, let's say, a successful model. Students learn from each other. But on the downside, it's and they work with castings. If you want to get into one of those, then you have to attend a casting, and if you fail to be cool enough, then you're not getting in. And that's really a bummer, because then you lack access to all of this knowledge that has been passed on from generation to generation. So the idea of knowledge transfer from student to student in non-hierarchical spaces was something that we were thinking about, and we were thinking that maybe we can use that model and scale it up into a large building that is for everyone. So we said, okay, this building has to be democratic in its form. Maybe that was also a little bit naive, but we said that the footprint of this building shall be a square, because a square doesn't have any front side, back side. It's kind of neutral in all directions, and then we put all the facilities like toilets and storages, we put it in the inside so that we free the facade. And we make it 2-story high because the plot was not big enough to have it all spread out. And we said that we don't want this to be a building that is separated by floor slabs, because we think that we believe that this is not good for communication. We rather wanted to have something three-dimensional, and then we also wanted something that is so non-hierarchical that it also has a decentralized access, so you can get into the building from all directions. And all this is then covered, surrounded by glass, like floor-to-ceiling glass facade, again, to somehow provide natural daylight to all areas. So there's no like hierarchy in between the spots in there. So everything has the same access to daylight. And then all this is covered by a roof, and the roof is also shading the glass facade so it doesn't overheat in summer. And at the same time, the system of platforms and stairs continues on the outside, so you can also use spaces in the exterior most of the year. So the building sits on campus like a bit of a microchip, and it sits within the already existing walkways of the students. And so here, there's the high-rise building with the architecture faculty. And it's let's say a bit of a problematic building because there are floor plans, floor slabs and floors stacked on top of each other, and there's no communication between those floors. And when I used to teach there, it was often that you would meet someone in Berlin and they were saying that you are teaching there as well. And it's like, yeah, and then I haven't seen you ever. It's like, yeah, because there's no common area. There's no such thing as bumping into each other by chance. The only way you would probably meet someone is in the elevator, and that goes for like 10 seconds. And so let's say for knowledge exchange and for social encounters, this high-rise building doesn't do a good job. And at the same time, on the other side, there's the auditorium, which is a space of single-sided knowledge transfer, which is fine, but it's also old school in a way. We believe that the real knowledge happens from student to student, as I said. And so we believe that this new building shall be somehow counterbalancing those two very, let's say, dominant typologies on campus. And therefore, it's a bit of a, let's say, a folding of the campus typology, topography, and it wants to create density and wants to somehow create random moments and encounters and create somehow social momentum. Because also, and we didn't know that back then, but since the pandemic, and now that I see that I'm also streaming this on Zoom, people are not coming to campus that often anymore, and you really need to create a reason for them to come to campus. And we said that we want to create a sort of home, a place for social exchange. And it's not a place where you produce, and it's more of a space where you be social. And so the question was like, how do we make that happen in detail? And we looked at these two references, which I already talked about a little bit, but this is Cedric Price, Fun Palace, very popular reference, I think pops up every now and then in architecture school. And it's about this space that is made by these like industrial scale structures, and within the structure, students are somehow, or like people are somehow free to change the space as they like. They can turn it into something different every day. And it's very flexible and it's three-dimensional, and it works with the idea of a sort of superstructure. And then this Jonas Friedman concept, which I already talked about, the idea of a movable architecture, scalable, and a primary grid where you can insert different programs. And so these two references were the starting point, and we said we also want to have a superstructure, but ours shall be small scale, not big scale, because we want this to be human scale, almost furniture scale, and we want this to be able to be changed around fairly easily, so without causing a major construction site. And that's why we wanted elements to be small and light. And so we believe that if a building is able to change, and if a building is flexible enough, it stays relevant for a long time and can therefore be safe from demolition. And but we also said, let's say it will be demolished one day, then we do want this to be taken apart and brought to another location and maybe put together in a different way. So we want it to be a modular structure that is designed for disassembly. So meaning that we were thinking about the dismantling of the structure while we were designing it. And so this modular structure is based on a very simple structural bay, which is this 3 by 3 meter steel frame, and then a timber platform sits in it, which is light. And when it's light, you don't need to have so much structure. And it's held in position by a stair, so it doesn't fall over. And this system then can be multiplied endlessly. And we put all the electricity wires into the structure so students can plug in wherever they want and then kind of create their own learning environment. And this furniture is light and movable. And so for the competition, we also handed in those drawings where we somehow created different scenarios within this frame. And then when I walked through here, I was actually seeing situations exactly like this. Like there's a wall that works as an acoustic absorber, but also works to pin up your presentation. And then there's people in front of it basically exactly look like this, which was amazing. And then this whole idea continues on the outside, so people can also use the exterior by having a sort of protection against the rain. And all this comes together in a certain density, like an anthill scenario. And these are competition drawings. So we really presented it as a system, as a kit of parts. And it was amazing how you actually, with very little, with a catalog of very little variations, you just have platform, bridge, and stair. You can create a lot of different things. It's really just these 3 elements. And then this plus daylight and atmosphere can then create ever-changing spatial experiences. And if I go there now, I always find new situations where like, oh, this looks really dreamy. And I see students kind of somehow sitting differently than before and making use of the space in unexpected ways. So we really thought about this as a system, as a kit of parts that we decided to put together like this. So this is just an example, let's say. And this is the structural system. It's everything is demountable. It has one profile. It's always the same 10 by 10 centimeter. So it's like this hollow steel section. And then the timber platforms, they just rest on those L profiles. The facade is just screwed onto it, so it can also be dismantled. The facade itself is always the same element. And then the handrails are also just bolted in, screwed in. And so with this system, it was very easy to construct the whole thing. The construction site was very quick, which made it fairly cheap, let's say. And you can see how they constructed it. They set up the primary structure, then they put in the facade, which is coming now, and then they started doing the exterior space. Yeah, and then we visited the construction site, which was also very emotional for us. First building happening, and you could feel the scale. And the construction site was a very clean construction site. There was no welding, and there was only there was a big crane lifting in the columns, but then the beams were all lifted in by this blue car, and there were just 2 guys, and they were just putting in the beams, and there was always the same detail, always just one screw, and you had to fix it, and it was very simple. And yeah, so the building opened one day. No, that was actually before it opened. That was when it was finished, but not furnished. So we took the chance to take pictures. And we took a lot of effort to get the acoustics right, which is very important. And we had carpet and these perforated ceilings and acoustic absorbers. And then we had the yellow curtains, which we made yellow in order to attract people to actually use them and open up and close them. And So it kind of indicates that this is a movable element. This is a beautiful space. It's a double height space with 4 fixed glass facade panels and a bridge. And in autumn, when the trees have less leaves, the sun comes in, and it's yeah, it's very beautiful. And then suddenly it was open, and students came, and it was very interesting to see how they were kind of creating their own learning environment. Some were preferring to sit in this kind of balcony situation that was facing inwards, and others sat together in groups. And yeah, naturally they somehow made the space their own. And also they started using the balconies in summer, which is very nice because you look into this green space on both floors. And then most exciting is when it gets dark, because then the building becomes transparent, like really transparent, and it's like an X-ray. And so we try to keep the facade free of material. So really the interior of the space becomes the facade and the way students use it. And it always looks different. And students also use all these doors. And it's at the very beginning of the campus, and it somehow puts the student as a social species on a pedestal somehow. And you know, back in the day, the lecture hall was always like the one architecture typology that was standing for a university campus. And now here it's this, and the university is very happy to somehow, they feel like they projected into the future of university campus. And yeah, and that is the end of my lecture.